this video, we'll be going through part 5 of our physics review. Here we have a car that is accelerating from 15 meters per second to 45 meters per second in 10 seconds. Number 1 is asking us to solve for the acceleration of the car. A lot of people, when they read this, they'll think that 15 and 45 are different accelerations. Well, if you can see that it's just meters per second and meters per second, it's going to be velocity. But when it's going to be meters per second squared, it's going to represent acceleration. Now, we know that our initial velocity is 15 meters per second, and our final velocity is just 45 meters per second. We also know our time to be 10 seconds. And now we can use some of our kinematics equations we learned in one of our previous videos in order to complete this question. If you remember, one of our equations were v final, or vx, equals vx naught plus acceleration times time, and this helps you find your final velocity. Well, one of the really nice things of physics is you can rearrange this equation to fit the needs of your question. So if we subtract vxo from both sides, and again, our goal is to isolate acceleration because that's what number 1 is asking for. We have vx minus vxo equals ax times time. And the way we did that is we subtracted vxo from both sides. And now we can see that the only thing left on the right side is time besides acceleration. So we're going to divide time by both sides. And that leaves us with a being isolated. So we have vx minus vx naught over t equals time equals acceleration. And then now we can just substitute in values and we'll get our answer. Well, we know that our final velocity was 45 as given in the problem right here. So we have 45 minus our initial, which was 15 meters per second, over the time given, which was 10 seconds. So we have 45 minus 15, which is 30 over 10 seconds. So we have 3 meters per second squared as our acceleration. And that's how you do number 1. And just to recap, we found the kinematics equation that we could rearrange in order to isolate for the variable we want, which in this case was acceleration. We used the first equation in our kinematics sheet, which again will be in a different video, and we rearranged it in order to isolate a, substituted in our values right here, and then we got 3 meters per second squared as our answer. Now, number 2 is asking us to find the distance traveled by the car over the given interval. Whenever it says given interval, it's just referring to the time, and the time given is 10 seconds. So we still have these same numbers, 15 meters per second as our initial velocity, 45 meters per second for our final velocity, and time as 10 seconds. Let's go ahead and look at our equations and see which one best fits this question. So here are the equations. Well, we just used this one to find acceleration. Now let's go ahead and see which one we can use to find the distance traveled. Well, remember, x is going to be displacement, distance, or some type of position. Then we have our initial position, initial velocity, acceleration, and we have time. Well, we already solved for acceleration, so we have all the variables in this question, so we could effectively use that equation. So now let's go ahead and use that equation, number 2. Now let's go ahead and use our second equation. Well, now if we substitute in our values, we can easily get the answer. Well, let's just assume it's going to start from 0. So we're going to say x, which is our final, equals our initial, which we assumed is going to be 0 meters, plus our initial velocity as 15 meters per second, times our time, which is 10 seconds, plus 1/2 times our acceleration, which is 3, times time squared. Time is 10, so we have 10 squared. So now we have 10 squared, which is 100, times 3 multiplied by 1/2, which is just dividing by 2. So we have 300 divided by 2, which is just 150. 15 times 10 is 150 as well. So we have 150 plus 150, and we get a total of 300 as our answer for x. So we're going to say our answer for number 2 is 300 meters. Again, your measurements such as meters, meters per second squared, meters per second, seconds, etc. are very crucial when stating your answer and doing your work. So those are our 2 answers for this review for part 5. I hope this video helped. If you believe it did, please consider like and subscribe. I'd greatly appreciate it. Comment below for any future video recommendations. Follow us on Instagram and remember to hit the bell icon for future video updates. Thank you.